Have you ever gazed up at the night sky and wondered if we're truly alone in the universe? This question has sparked curiosity in humans since time immemorial, and it is this very curiosity that has propelled us to the forefront of exoplanetary research. You see, our universe is home to an estimated 2 trillion galaxies, each brimming with billions of stars. Orbiting these stars, hidden in the vast cosmic ocean, are exoplanets. These celestial bodies, found beyond the familiar boundaries of our solar system, hold the potential to answer our age-old question. Recent advancements in technology and science have allowed us to delve deeper into the universe, making astonishing discoveries about these mysterious exoplanets. Our quest to find life beyond Earth has led us to these distant worlds, and with each new discovery, we inch closer to unraveling the mysteries of our universe. The answer to this cosmic question may lie within the study of exoplanets. Scene script. First, it's important to understand what we mean when we say exoplanet. When we gaze up at the night sky, we're not just seeing stars, but potentially thousands of other solar systems. In these systems, just like our own, planets may be orbiting around their respective stars. These planets are what we call exoplanets. The term exo is derived from the Greek word for outside, so exoplanet literally means outside planet or planet outside our solar system. Exoplanets are incredibly fascinating, not just because they exist beyond our solar system, but due to the potential they hold. They could possess the right conditions for life as we know it, or they could be so vastly different from anything we've ever encountered that they redefine our understanding of planets. So, how do we find these cosmic curiosities? It's not as if we can simply point a telescope at a star and see the planets orbiting around it. Most are far too distant and dim. Instead, astronomers use clever techniques to detect these far-off worlds. One such method is the transit method. This involves observing a star for an extended period of time and watching for any slight dimming in its light. This dimming could be caused by a planet passing in front of the star from our perspective, essentially creating a small eclipse. By measuring how much the star's light dims, and for how long, astronomers can infer the size of the planet and its distance from the star. Another technique is the radial velocity method. As a planet orbits a star, it exerts a small gravitational pull, causing the star to wobble slightly. By observing this wobble, astronomers can determine the mass and orbit of the planet causing it. These methods, along with a few others, have allowed us to discover thousands of exoplanets, and not just any planets, but a diverse array of celestial bodies, each with their unique characteristics, from gas giants larger than Jupiter to rocky worlds similar in size to Earth. With these methods, we have discovered thousands of these celestial bodies, each with their unique characteristics. These exoplanets, as diverse as they are numerous, exhibit a wide array of unique characteristics. Let's take a cosmic tour of some of these otherworldly realms, starting with the gas giants. These are planets that, much like our own Jupiter and Saturn, are composed primarily of hydrogen and helium. They're typically massive in size and are often found in close proximity to their stars. This can result in extreme temperatures and violent weather systems. Imagine a world where storms rage with winds of thousands of miles per hour and clouds made not of water but of molten glass. Next, we have the ice giants. These frigid worlds, similar to Neptune and Uranus in our own solar system, are composed largely of heavier volatile substances such as water, ammonia, and methane. They're usually located further from their stars, leading to incredibly cold surface temperatures. Picture a world where the skies rain diamonds and the surface is covered in a vast frozen ocean. Then there are the rocky planets. These are akin to Earth, Venus, Mars, and Mercury. They're characterized by their solid, terrestrial surfaces. Factors such as their distance from their star, size, and atmospheric composition can greatly influence their climates and geologies, creating a spectrum of worlds from scorching, barren wastelands to potentially lush, life-bearing planets. Lastly, let's visit the lava worlds. These are rocky exoplanets that orbit so close to their stars that their surfaces are perpetually molten. Imagine standing on a world where the ground beneath your feet is a roiling sea of lava, and the sky above is a blazing inferno. These distinct types of exoplanets are shaped by a myriad of factors, including their distance from their star, their size, their composition, and the age of their system. Each of these elements contributes to the unique characteristics we see, painting a vibrant and diverse portrait of the cosmos. These unique characteristics give us clues about their potential habitability. They beckon us to continue our search, to delve deeper into the mysteries of the universe, and to keep asking that age-old question, are we alone? But how do we determine if these exoplanets could potentially harbor life? Well, the answer lies in the concept of the habitable zone, or as it's more whimsically called, the Goldilocks zone. This is the just right range around a star where conditions might be perfect for life as we know it. Not too hot, not too cold, but just right. In this zone, the temperature allows for liquid water to exist on a planet's surface, a crucial ingredient for life as we understand it. The habitable zone varies from star to star. For instance, a smaller, cooler star's habitable zone would be closer in, while a larger, hotter star's zone would be further out. Picture a campfire on a chilly night. You don't want to be too close and risk getting scorched, but you also don't want to be too far away and freeze. It's the same principle with stars and their planets. Now, finding a planet in the habitable zone is exciting, but it's not enough. To truly know if an exoplanet could host life, we need to find evidence of liquid water. And that's where things get a bit tricky. Scientists use sophisticated telescopes to look for signs of water in the atmosphere of these distant planets. They analyze the starlight that passes through the planet's atmosphere. Different molecules, including water, absorb light in unique ways, producing distinct fingerprints that scientists can identify. Yet, even if we find water, that doesn't guarantee life. Mars, for instance, has evidence of past water, but so far no signs of life, but it does increase the odds. And in a universe with potentially billions of Earth-like planets, those odds are not insignificant. The search for habitable exoplanets is a bit like searching for a needle in a cosmic haystack. But each discovery brings us closer to answering that tantalizing question: are we alone in the universe? Finding a planet in the habitable zone is a significant step in the search for extraterrestrial life. So, what does this all mean for the possibility of life beyond Earth? As we delve into the vast expanse of the cosmos, we're continually uncovering new frontiers, each more intriguing than the last. The discovery of exoplanets has opened up a whole new realm of possibilities, each one a unique world with its own set of characteristics. While we have yet to find definitive evidence of life beyond our own planetary doorstep, the sheer number of exoplanets we've discovered suggests that the conditions necessary for life could exist elsewhere. It's a tantalizing thought, isn't it? The idea that somewhere out there, on some distant exoplanet, life could be thriving. Consider this. In our own solar system, life exists on a single planet, but in the grand scheme of the universe, our solar system is but a tiny speck. The number of known exoplanets is in the thousands and growing every day. Each one of these could potentially harbor life, making the odds of finding extraterrestrial life increasingly favorable. However, it's important to remember that habitable doesn't necessarily mean inhabited. The conditions on these planets may be right for life as we know it, but that doesn't guarantee that life is there. It's like finding an empty house with all the necessities: food, water, shelter, but no one is home. Yet the possibility remains, and it's that possibility that drives our search. As we continue to discover and study these distant worlds, we're not just looking for planets, we're looking for possibilities, we're looking for answers, we're looking for life. And with each new discovery, with each new frontier we explore, we come one step closer to understanding our place in this vast, cosmic arena. So, as we stand on the brink of these new horizons, let's not forget the wonder and the potential they hold. The universe is vast and full of mysteries yet to be solved. As we continue to explore the cosmos, we inch closer to answering the question: are we alone in the universe?